Welcome to the Converging Systems webinar series on the topic of a successful integration between Lutron LEAP-enabled platforms, including HomeWorks QSX, RadioRA3, and Athena, and the Converging Systems eNode 4000 series of gateways. This webinar will allow you to successfully set up one of these compatible Lutron systems to control connected lighting or motor devices linked to the eNode 4000, 4100 gateways. The core of the integration is the eNode gateway. Embedded within the gateway is our proprietary Lutron interpreter module, referred to as the SLIM processor, which has been refined and newly relaunched to work with the Lutron LEAP protocol. The SLIM processor enables tracking of real Lutron keypads and loads, including physical loads such as Ketra, standard lights, as well as the tracking of Lutron hardware button presses, such as from C-Touch and other keypads that manifest themselves as a press, a release, a multi-tap, a hold. And finally, it can track loads triggered by the Lutron time clock events and other occupancy sensor events. In addition, we can track phantom keypads and loads as well, which are created for special purposes. That would include button presses to trigger special features and monitoring of loads to utilize, again, Lutron user interface screens to control our hardware devices. Now let's get started. What is required? As far as Lutron equipment is concerned, you need one of the supported processors, the RadioRA3, the HomeWorks QSX, or the Athena platforms. As far as Converging Systems equipment is concerned, you need at minimum an eNode 4000 or 4100 with built-in PoE. We also have an optional wall wart that provides 12-volt power where PoE switch is not available. And then any required physical ILC, intelligent lighting controllers, IMC, intelligent motor controllers that are compatible with the eNode platform, and in the DMX world, any number of virtual DMX fixtures that have been added up to 32 per eNode. Finally, as far as the network is concerned, you need an available LAN connection that both the Lutron and the Converging Systems gateways will plug into. Now let's get started. The first steps for integration will be to engage with Lutron Designer software. You must create an integration login for the eNode, which includes a unique username and passphrase. Now let's get started. The first step on integration is to determine the type of functionality that is required from the Lutron controlling platform. We have divided these levels of capability into three modes. Mode A is where Lutron has been programmed initially by the installing dealer to control its own set of devices. Mode C is a situation where Converging Systems products can actually monitor or track existing Lutron operations and, if you will, go along for the ride. Mode B is an interesting case where unique CSI operations are required separate from any Mode A operations. So let's go over the theory of operation and how these activities work. Number one, called load tracking. Load tracking is the simplest form of functionality. For instance, if there were a Ketra bulb in the installation, or where a phantom Ketra could be added, the Lutron user interface would control the Ketra bulb and an eNode supported lighting element concurrently. Parameters are passed between the Lutron processors and the Converging Systems gateway that provide information on a number of features, including hue, saturation, brightness, color, temperature, on-off conditions. There are some features currently, such as vibrancy levels, fade time, and natural show tracking that are either work in process or not currently supported. There are workarounds which we'll explain later on how at least some of these features can be tracked with native features within the eNode 4000, 4100. In addition, there are some special feature characteristics that can be tracked as well. These include loads triggered by time clock events, loads triggered by occupancy sensor triggers, outputs from a 0 to 10 volt device, and also purely monitoring standard monochrome loads. It is important to understand how the SLIM processor within the eNode can track Lutron button presses. Within Lutron Designer, the installer initially programs a button for its particular type, whether it's a press, a release, a double tap, or a hold. Only if a button is programmed for a particular action can we receive that particular action within our Lutron table configuration. So therefore, if a button is set within Designer to be a press, we can track a press. Similarly, if a button is set for a toggle, we can track a toggle, but we must know in advance the type of button that we're tracking. There are particular situations where phantom loads and phantom devices need to be created within Lutron Designer in order to enable the SLIM processor to operate properly. In this case, there are several examples where a creation of a phantom load or a phantom keypad is desirable. Further information on the creation of these loads can be found at the web link below. Now let's summarize. The steps that have been taken in the last few slides with respect to the Lutron processor and Lutron Designer software are as follows. You need to have verified that the programming of the Lutron processor included a static IP address. Number two, you need to have verified that the integration login credentials for the Lutron processor through Designer have been created. Next, you have to make sure that the type of operation desired by the eNode and the accompanying system, including the type of button presses or triggers, whether a phantom keypad or phantom load is desired, have all been made and have been properly uploaded to your processor. And finally, make sure that you're running the latest release versions of the eNode 4000 and 4100 firmware. For more information, see the link below. Next, let's get started with the eNode. Make sure it's properly plugged in and connected to your local area network. Then, using Windows File Explorer, go to the Network tab, hit Other Devices, and you should find its name appearing in the list. Double-click on its name to expose its web page, and then hit the icon at the upper right-hand corner to enter its settings page. Go to the Lutron tab and select the appropriate Lutron platform under the pull-down box that you wish to interface with in this case. Next, enter the IP address, the login credentials, and select Enable to activate. You'll have to wait about 15 seconds or 10 seconds for the TLS encryption to occur between the Lutron processor and the Converging Systems hardware. Finally, upon successful completion of that connection, you will see the word connected. Unless you see the word connected, you cannot proceed to the next step. Make sure you've entered all your information right, and then oftentimes by hitting connection disable and enable once again, a proper connection will be found. Discover all the Lutron devices that have already been programmed into the Lutron system. Go to again the Lutron tab under Devices, pick the spyglass selected, and wait approximately 20 seconds for all the devices to be successfully passed into the eNode's web page. The key to Lutron connectivity using the SLIM processor is the Lutron table shown here. Each line underneath the table can accommodate one set of events that will monitor an event from Lutron and a resulting action from an eNode 4000, 4100 device. Through the use of pull-downs in each line for each data segment, specific commands and entries and values can be entered. The examples in the following slides will show exactly how these tables can be used to practically program anything that you desire. Now let's get into some examples. But rather than documenting further how the above processes have been designed, let's actually pick some popular use cases that will be useful to assist you in your programming efforts. First case is a use case where there would be no applicable load to track, but simply a button push is desired to be tracked and to evoke an action on a converging system side. So in this case, we're looking at a 10-button desktop keypad. The upper right-hand button is referred to as button 1. We would like that particular button to create a certain color output using the hue, saturation, brightness color space of green. The connected device will be referred to as the ILC400E, which would have been discovered, and its zone group node address would be programmed to be 2.1.1. Now let's program our first step. Find an available empty row under Lutron table, right-click, and among the entries in the pull-down, select the applicable device with which you wish to connect. In this case, pick the 10 desktop. Next, under button, you will select a button number. Choices that are supported will be available in the pull-down. If you're unclear of the button numbering scheme, hit the button question mark hyperlink to learn more about button numbering. Finally, under action, allow pull-downs to display the various choices that are available. In this case, we want a button press, which is the way it was programmed inside of Designer, to actually be used as our trigger. So press, and finally hit the arrow in order to program and to continue. Now we are going to advance to the next data entry area under address. The address is the ZGN zone group node address of your IMC or ILC pre-programmed device. Right-click and select the various device that you desire to connect and hit enter. In our case, we're going to pick the ILC400E, which is the device in our example. Next field is under device. Right-click and select from available choices. In our case, this is an LED. Next data field is the actual command that will be triggered. On the same row as the previous entries, right-click on the pull-down to find available choices. We will pick here HSV for hue saturation value or hue saturation brightness. This is our recommended color space. And finally, to complete the entry for the color setting, we will enter a value in the hue saturation brightness color space as indicated below. The range and the values are listed on this slide. You may want to take notes for further purposes. We've mentioned that the Lutron LEAP protocol does not currently pass dissolve rates that have been programmed within Designer. However, we have a special feature within the table programming that allows a customized dissolve rate to be entered manually. See in this example, you use a colon, you type in a number and the number of seconds, and that will then be the appropriate dissolve rate to get from an off state to this state or an on state to this state, whatever is relevant. Specifically within the eNode hardware, we have default dissolve rates that can be set up and learned about under other documentation within the eNode. Whichever dissolve rate comes last prevails. So in the case of this table programming, the 5 that's shown here will actually prevail. The next example is a typical scenario where buttons can be used for fading up and fading down. And the concept is you hold them down as long as you want the action to occur, and you release the button it will actually invoke a stop and stop the process. In this case, on a desktop keypad, buttons number 24 and 25 are the lower and the raise, and we'll be going through an example where the same device and the same address of device will be used to actually learn an additional concept of button control. First, select a free row under the Lutron table programming section. Scroll down and under Lutron ID, select the tin desktop device selected in the previous example. Under the button category, scroll down and select button number 24, which is the fade down button. Under action, select press, and finally hit the upload arrow to proceed to the next step. On the same row as you just entered the keypad information, scroll down under the address column to select the controller that will be connected with this action. Let's pick the item that was picked in the previous example, the ILC400E, and under device, as before, picked LED. Now, finally, under command, scroll down and pick the fade down command. This is what your line will appear as, showing the Lutron ID, the zone group node address, the device type, and the command. Now we will repurpose the button that was just selected to have an alternative purpose. The release of that button will be a stop. In Lutron programming techniques, the fade down and fade button always have this capability, but we need to be able to track the differences between the press and the release. In this case, add a new line with the same device, the same ZGN, the same device type LED, but in this case, pick stop. Now we will continue and create another set of buttons for the fade up requirements. In this case, you'll see from the table that we picked button number 25 with the same ZGN address, the same device type, but in this case, we picked command of fade up. And similarly, for the second line, we picked the same entry, but we picked the command stop. In summary, what has been programmed is the capability of having two functionalities present on a button press. In this case, the fade down will continue turning on our dissolve processor until such time as the button is released. Similarly, when the fade up button is pressed, our fade up processor will be invoked and will continue until such time as the button is released. Here in this example number 3, we will be utilizing a Lutron QSX platform. We'll have a Ketra fixture installed. We will also have an eNode 4000, 4100 controlling a full spectrum lighting device. Now, as before, select a free row and right-click at the location of the green arrow to go pick, in this case, the hardware device called Ketra. Next in the sequence, under button, accept the dimmer default, and this should only be used for track loads in this case. All the other choices of press, release, multi-tap and hold are not applicable when tracking loads. Next in the sequence, select the action type. In this case, it's hard-coded to level. And finally, hit the icon to upload the program and proceed. On the same row as in the previous step, scroll down under address, select a device such as we picked before, the ILC400E, and next in sequence as before, select device, LED. Now on the same row as your previous programming entries, under command, scroll down and find the set, command, and select. In this case, we will not enter a value under value, for the 0 under Lutron ID instructs the Slim processor that we will monitor a wildcard of parameters that come through the system to set all the appropriate parameters that are supported. However, you do have the capability of putting a colon and a second entry, such as seen below for 5 seconds, if you want to make it match what was done inside of Designer for the same dissolve rate. The next use case will be a typical scenario where circadian lighting is desired on any LEAP platform, regardless if natural show is provided on the platform that you're utilizing. This example 4 is a situation where the natural show is running on a QSX processor, but you have an interest in having a similar natural show running on the eNode 4000, 4100 gateways. For more information on how to program this, go to our Converging Systems website under Resources, Automation Partner Drivers, Lutron, and find more information there.